Alright, this video is going to look at the 5 parent functions that we're using in Unit 2 that you have to be able to do transformations for. So the first one is the absolute value, okay? And so that's y equals, or f of x equals, the absolute value of x. Remember, this is a V-shaped graph, and it has something called an axis of symmetry, which is a vertical line that goes straight through the middle of it. Alright, and it also has a minimum or maximum depending on whether it's a upward facing V or if it's flipped down. That minimum or maximum point is called the vertex. Okay, so here we have the regular parent function, the absolute value of x. If I plug these numbers in, the absolute value of -2 is 2, 1, 0, 1, 2. And if I graph those points, it's going to give me that V-shaped graph. Alright, and then of course this goes forever in both directions. Okay, so the vertex, the bottom of my V here is 0, 0. My axis of symmetry is a vertical line, so it's x equals, and it always has to go through the vertex. So my vertex is at 0, 0, so my axis of symmetry is x equals 0. Vertical line right here that cuts this graph in half, and if I fold it over, everything would match up. Alright, my domain, this graph goes left forever and right forever, so it is all real numbers. Again, there are two ways to write that, so I can say that x has to be between negative infinity and positive infinity, or I can say x is an element of the real numbers. Either one of those is the same thing. Here on the range, my graph goes up forever, but going down, it stops at 0. So two ways to write that. 0 is less than or equal to y is less than infinity. So my graph goes from 0 all the way up to infinity. Or y is greater than or equal to 0. Second parent function is the quadratic function. All right, y equals x squared. This is a U-shaped graph. And the name for that is a parabola. Hopefully you remember that from Algebra 1. Okay, it also has an axis of symmetry and a vertex, just like the absolute value graph. So if I plug these numbers in, -2 squared is 4, -1 squared is 1, 0, 1, 4. Okay, so let me graph those. And that will give me that U-shaped graph. Okay, and again, axis of symmetry goes right through the middle, through the vertex. So my vertex is 0, 0. My axis of symmetry is x equals 0. Domain, graph goes left forever and right forever. So between negative infinity and positive infinity, or x is an element of the real numbers. Range is the same as the absolute value. It's between 0 and positive infinity, or y is greater than or equal to 0. Alright, our third parent function is the square root of x. Alright, it's also known as a radical function. It has a restriction because you cannot take the square root of a negative number. So if I try to plug a negative number in here, the square root of -4 is undefined. I can't do it. Same thing for -1. The square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. So when I go to graph these, I can't graph anything in the negative x values. So I have 0, 0, I have 1, 1, and then I have 4, 2. Alright, so the graph goes a little something like that. Alright, my domain, it goes to the right forever, but on the left side it's going to stop at 0. So 0 less than or equal to x less than infinity. And my range is going to be the same. The lowest it goes is 0, and then it keeps going up forever. Alright, and again, both of those could be written in a little shorter way. We could say x is greater than or equal to 0, and y is greater than or equal to 0. I would accept either of these as a correct answer. Alright, the next parent function is called a cubic function, and that's y equals x cubed, or x to the third power. Okay, so when we plug these in, -2 to the third power, that would give me -8. Alright, -1 to the third power is -1. 0 to the third is 0, 1, 1, and 2, 8. So when I graph this, let's graph this and see what it looks like. So negative 2, negative 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 1, 0, 0, 1, 1, and 2, 8. So this is what the x cubed function looks like. All right. When we talk about the domain, it goes left and right forever. All right. So again, negative infinity and positive infinity, or x is an element of the real numbers. It also goes up and down forever. So my range is the same as my domain, or we can write it as an element of the real numbers. Okay. And that's what the x cubed function looks like. The last one that we're going to look at is the opposite then, the cube root of x. Okay, so if I take the cube root of negative 8, that would give me negative 2. The cube root of negative 1 is negative 1, 0, 1, 2. So that is going to be very similar to the x cubed function. All right, and except that it's going to kind of flatten out and go sideways really fast, whereas the x cubed function flattened out and went up and down really fast. Okay, domain and range though are the same. This goes left forever, right forever. It goes up forever, down forever. So between negative infinity and positive infinity for both. Or we could say that x is an element of the real numbers and y is an element of the real numbers. Okay, so those are the 5 parent functions that we're going to look at, that you kind of need to know the general shape so that you can judge and graph transformations of those functions.